Welcome to the Weather Insights podcast. Should we call this a special edition? Special edition Ask Weather Insights.
But we're just answering questions. This isn't this isn't a podcast, or
Well, it's whatever we want.
because we could just cut the whole.
Yeah, no, we'll do it as a whole podcast if people want to, listen to it and hear the answers to any of these questions, and maybe come up with their own for future podcasts. Anyway,
Some better ones.
yeah. Well, I'm meteorologist Scott Pitney, along with meteorologist Jeff Lindner at your service. And yeah, so we asked our viewers to ask us some questions, and we'll do our best to answer them. And you can follow along by watching the podcast. We're going to post some of these on TikTok too, if it's still around.
Yeah, maybe gone.
We'll see.
Who knows?
We decided to do this all before the TikTok news broke. But yeah, we'll post them there too as individual videos, but we'll have the whole podcast here. So let's jump right in. Well, before we jump in, how are you doing?
I'm fine.
All good?
I got some pollen thing going on in my throat, but besides that, great.
Yeah, it's nasty, right?
It's very nasty.
Yeah, but that's March in Houston.
Needs the rain to wash it out.
Yeah, we could use that for sure. Yeah, we need to get some rain going because it's going to be a dry summer, so we need to get the reserves up and all that stuff. But anyway, we talked about that last podcast, so be sure to watch that podcast to get an update on the rain, La Nina, El Nino, hurricanes, wildfires. That was on the last one. So anyway, let's jump into our first question. Do we want to start off with the snow question?
Sure, because we're so good at it down here.
That should be very quick.
Yeah.
Christian from Norway, of all places.
Is it snow in Norway?
I think so.
I don't really know.
Yeah. No, I've been there. I saw snow. I did see snow. So yes, I can check that box. It does snow. From Norway asks, why is the amount of snowfall the hardest thing for meteorologists to forecast? I think there's a two-part answer in my mind for this. One of the factors is, and again, we're in Houston, so I am no snow expert. It's been a long time since I've seen actual snow here, like that's been on the ground. But that part of it being on the ground, it falls in different forms, different size flakes, and that makes a big difference. If you got the big flakes, it can pile up a lot more measurable snow than if you have the smaller flakes or graupel or things like that. I think that's one of the factors. And then with rain, I mean, you look in the atmosphere, it's moist. I mean, it just falls in one form. It's pretty easy for us to go in and look at PWAT values and things like that. But with snow, it could be a little bit trickier because you might have some warm layers, and you got to have you got to look at the temperatures through the whole profile. Mm-hmm. I think, which makes it a little trickier. So anyway, and the other, I think, major thing is, and this can happen with rain too. It just depends where the snow line's set up, especially with lake effect snow. I mean, you can have 12 inches of snow in one spot and just a few miles away have an inch of snow or almost nothing. And to me, it's the equivalent of us in the South, forecasting, convective showers and thunderstorms in the summertime. But we can say 20%, which the whole area has a 20% chance of getting rain, but exactly where and when that's going to happen, we don't really have that capability yet. We're getting there. We're making progress. So
I think the difference maybe between snow typically is not as convective. It can be. There can certainly be banding, and where banding sits up, obviously you get heavy totals, and like you just said, it's very hard. This isn't sometimes as easy as there's not really outflow boundaries and surface boundaries. There can be, but a lot of this stuff happens higher up in the atmosphere with snow. And so you get this banding, especially in like nor'easters and stuff like that. And most snow events are more synoptic scale. There can be a mesoscale aspect to it. And like you said, P-type is probably the biggest thing. If you're snowing and you're mixing in sleet or ice pellets, that's going to cut down your accumulation. Or if you're mixing in rain, Or if your temperature's 34, some of it's going to melt. Some of it compacts. If it's a dry, really cold, and it's a dry snow, it's going to blow around and it's going to drift, and so your amounts are going to be higher. You get what you get that falls from the sky, but then it drifts in areas, and so you get higher totals. And how people measure it, there's actually a way to measure snow. You're supposed to put down a board and measure off that board. You're not supposed to just go out and measure off of different things and everything like that. And so it's way more complicated than rainfall, and I'm glad I don't have to deal with it very often down here.
Yeah, I second that. And when Jeff says P-type, he means precipitation.
Type, yeah.
Type, yeah. We use a lot of acronyms and abbreviations in meteorology. So
Makes it sound smart.
yeah,
Makes it sound smart.
it does. It's a long list of them too. I don't even know probably 10% of them. Joe, thanks, Christian, by the way, for that question. Great question. Joe from Pasadena, California asks, does water stay suspended in the atmosphere? Well, great question, Joe. The atmosphere is made up of air parcels, and each of the air parcels contains a certain amount of air and water. And when the area is more dense around the parcel, then the parcel will float and stay suspended. But if the parcel condenses and becomes dense, and the molecules start combining and forms a raindrop and gets heavy and dense enough, then gravity pulls it to the ground. So anyway, that's a quick quick answer to.
It's a physics. We could get some equations.
Yeah, you could write a book on this one. But
yeah,
anything to add to that?
It's kind of an interesting question. I think when people say water, do they mean raindrops? How does hail stay suspended in the atmosphere? Obviously, hail is heavy, and you're right. I mean, as what we call updrafts, or the air moving vertically in the atmosphere in showers and thunderstorms, helps suspend those rain droplets aloft until they become heavy enough to overcome that velocity that's pushing them up. So at some point, that raindrop will become heavy enough that it begins to fall back towards the surface, or hail or whatever. And hail can go through several cycles. So if you cut open a hailstone, you'll see these rings in it, and that's how many cycles that hailstone went through moisture. That layer of moisture froze, produced a layer of ice, produced a circle. Then as it falls, it goes back through that moisture again and accumulates. This is probably better explained in a graphic than us trying to talk about it. But generally speaking, yeah, that's how moisture is suspended. I mean, it's really no different than fog. Fog is suspended moisture. Clouds are no different than fog. And so, it's light enough that it's suspended in the air as water vapor.
Yeah, and it is saturated. You can see it because of light refraction. So, but it's just not heavy enough to fall as rain.
Correct. Yeah.
Yeah. So, good question, Joe. Interesting question. Yeah, and it takes. By the way, when you talk about suspending hailstones, and you're up to baseball size and softball, it is a tremendous amount of wind speed, updraft, to keep those things suspended. So, yeah, that's interesting weather when that happens. Thank you, Joe, for the question. Darcy from Michigan asks, what's the difference between sleet and hail? Well, we already touched on hail a little bit. Sleet is basically snow. It started off as snow, and it fell through a warm layer and melted and became sleet and falls to the ground as a pellet, where hail, as Jeff just kind of mentioned, is more a thunderstorm updraft type event.
Yeah, sleet's generally cold.
Yeah,
when it's cold outside, and hail's generally when it's warmer and thunderstorms. There's differences between the two, but ice falling from the sky is ice falling from the sky. So yes, we can call it whatever we want. But sleet is usually, you can get sleet temperatures in the 40s. Typically, it's colder temperatures in the 20s and 30s. It'd be rare to see hail with temperatures that low, although I guess you could get it elevated elevated thunderstorms, which are above the surface, with temperatures in the 40s. We've seen that before down here where we live. But yes, hail is a convective thunderstorm event, if you will. Tends to be larger than sleet. Sleet tends to be very small. A big sleet pellet would be the size of a pencil eraser. That's huge. And so most of it is the size of a pen tip, or maybe a little bit bigger than that. And it's just little dings. And again, sleet tends to not occur when you have a lot of lightning and thunder. It can, I don't know, everything we're saying here, there's exceptions to all of it.
Right. It's weather.
When we're dealing with the physical sciences.
Right.
But that's the way I look at it. Sleet's cold and hail tends to be warm.
Yep.
Warm season.
There you go. Darcy, thanks for the question. Allie from Washington wants to know how frost forms on the ground. Well, frost, I used to wonder about frost as a kid because you'd see it on the rooftops and you'd see it on the grass, but the temperature, the air temperature was cold, but it wasn't freezing, maybe 36, 37 degrees. Well, the air heats up and cools faster than the ground. So sometimes those surfaces, and then the frost starts off as dew that basically freezes. So sometimes those surfaces stay colder for longer periods of time than the air, and that's why you see the frost. Let's see, what was her question? She asked why it forms on the ground, but I think that answers it. Anything?
Well, a lot of times the temperature, where people see that, when you see the temperature on the news, a lot of those temperatures are taken above the ground. So I think, what is it?
Yeah,
6 feet or 6 meters or 3 meters. I don't know, whatever it is.
Yeah.
And so cold air sinks. Cold air is heavy. So the coldest of the air is going to be right where your feet are, not necessarily at the temperature sensor, which is above where your feet are. And so it can be 32, 33, 31, and the temperature sensor is reading 36, 35. And so that's why a lot of times you see frost, especially on the ground on a clear, cold night. And you have to have a night where you have just enough moisture. It can still be dry by what we would call dry, but you have just enough moisture where that temperature gets very close or equals that dew point. Hence, when dew forms, the dew point.
Yeah.
And that's when the dew forms. And then usually mid 30s, possibly even upper 30s. But right at the surface, you can be a little bit colder and you can form some ice and stuff. And so, and the other thing is, anywhere you see like depressions, like around creek beds and stuff like that, away from trees, out in the clear open, that's where you're typically going to see frost and stuff like that. So the rooftop example is a little different because the temperature is a little bit warmer at that height, but you do see it on rooftops. You do see it.
Yeah, especially when the sun comes up in the shaded areas. It's just a matter of heating. Plus the heat from the inside of your house, it kind of tends. You can look around the neighborhood and see who has good insulation. So, all right, thank you for that question, Alan. Let's go to Paula from Pennsylvania. Asks, what's the difference between El Nino and La Nina? Wow. There's another one that could be answered with a book, but great question, Paula. So I can tell you what I'll talk about the weather patterns maybe, and what we typically see during an El Nino period, which is what we're in right now, and it's a fairly strong El Nino. We're about to start coming out of it. In fact, we may already be. I think Pacific Sea Surface temperatures are indicating that. But we tend to have a wetter, colder pattern in the south, and up north, it's just the opposite. It's warmer and drier. Well, when that shifts over to La Nina, we get a warmer, drier pattern, which is what we had last summer. Is why it was just so hot in the south and so dry, and we had all the drought and the fires and everything else happens during La Nina, and the wetter, colder stays up north. These are very general type observations. Obviously, anything can happen. it just doesn't stop raining in the south during La Nina. But these are just general patterns that we see during these oscillations.
I mean, the question, the difference is the sea surface temperatures in the Pacific, in the eastern central Pacific. So from off the coast of South America west to south of Hawaii, that is the area we look at as one of the bigger determining factors if we're in a La Nina, El Nino, or neutral. And El Nino would just be sea surface temperatures in that region a half a degree Celsius above normal. La Nina would be the opposite, a half a degree Celsius below normal, and then neutral sandwiched in between the two. So plus a half a degree to minus half a degree. Once you start getting over 1.5 either way, it's classified as strong. So negative 1.5 would be a strong La Nina, opposite for an El Nino. But I mean, that's the simplest way to look at it, as kind of the sea surface temperatures there. But there's other ways that we look at and classify El Nino, La Nina, the pressure differences, the surface pressure differences in the Southwest Pacific, and also the kind of what we call the Southern Oscillation Index, which is, it kind of indicates how the atmosphere is coupling with the ocean temperatures, because ocean temperatures drive a lot of our weather. And it's not just the El Nino, La Nina in the Pacific, but also, if you look at the ocean temperatures in the North Pacific, around Alaska, and also, of course, in the Atlantic, all of that can be drivers in weather patterns. And so simply, it's warm water is El Nino, cool water is La Nina in the East Central Pacific. And it tends to reach its maximum of either way in the northern hemisphere, late fall through early spring. Yeah. So we're talking November through February, kind of peaking in December, January time, around Christmas time, actually. And so that's kind of the boiled down. And like you mentioned, there's impacts in the United States and there's impacts globally also. I mean, there's impacts in Australia, there's impacts in the Southwest Pacific Ocean and the islands out there, all driven by what's kind of going on with the sea surface temperatures in the Pacific.
In case you ever get this trivia question, the pressure differences, specifically Jeff mentioned Southwest Pacific, it's Tahiti.
Right.
And then the
Darwin,
other,
right?
Darwin, Australia is the other point. So they just want to be consistent. So they're collecting consistent data each year. But and then with the difference in pressure and the seas, it's just amazing to me that little of a difference, 1 to 1.5 degrees, can change the whole world weather pattern. That's pretty amazing, really.
I mean, we don't think of it as a lot. I mean, we think of the temperature as 20 degrees difference between morning and afternoon. But when we talk about oceans, when you talk about water, you talk about a pool. For example, if you have a pool that's not heated, you realize how much energy it takes just to heat a pool.
Yeah.
Like just from the sun trying to heat that pool. Imagine trying to heat up a portion of an ocean.
Yeah.
It takes a tremendous amount of energy to heat that amount of water. And then that energy is stored in that water. And so, I think when you start talking about, it's a degree or a degree and a half, that's nothing. But the amount of energy that's in that degree or degree and a half or 2 degrees is really significant, and it changes the where thunderstorms form in the tropics. And when you change that, it can change the upper level jet stream patterns and more complicated things. And so that's that whole coupling. It starts with the sea surface temperature anomaly, but then it couples with the air mass over time based on where the tropical thunderstorms develop. And what happens in the tropics is very, very important for weather worldwide. I don't know if people realize how important not tropical activity, not hurricanes and tropical storms, they're important too, but just thunderstorm activity in the tropic area between 30 north and 30 south or near the equator is very important worldwide for jet stream patterns and stuff like that.
Yeah. we have the Hadley cells and all those things working with
Right.
that. And then, and then this El Nino, La Nina, it has an effect on our hurricane season too, because of the trade winds and the effect it has on wind shear. With La Nina, the wind shear's patterns get lighter, and that's when we see more hurricanes form. So anyway, again, we can go on and on. That's a great question, Paula. Lots to go in there, but I think Jeff boiled it down very nicely. Thanks for the question, Paula. Dan from New Jersey asks, what causes a busy hurricane season? Well, I just kind of stepped into this one. Dan from New Jersey asks, what causes a busy hurricane season versus a slow hurricane season?
Well, there's a lot there that can go into that. Your key factors for hurricane season are sea surface temperatures, and I assume we're talking about the Atlantic Basin.
Yeah.
So the Atlantic Basin is the Atlantic, the Gulf of Mexico, and the Caribbean. And so sea surface temperatures are a big thing. We always look at sea surface temperatures. If the warmer the water, the more potential there is for storms to strengthen, not necessarily form, but strengthen. Wind shear is a big thing. So you can have 90-degree water temperatures, but if you have really strong wind shear, that's winds above the surface. It's going to be really hard for storms to form. Storms don't like wind shear. Thunderstorm tropical systems don't like wind shear. They like light winds aloft. They like to bring all that surface convergence in toward their center. That's how you get the whole eye forming and all that kind of stuff. And they like a very light pattern where the winds at the top of the hurricane are actually spiraling outward. So all this rising air is coming into the center of the storm, and it has to go somewhere. You can't just keep pumping air into the center. It has to go somewhere. So it goes up and then out. And if you have wind shear, it can't really get out as favorably at the high levels. 40,000 feet is what we're talking. And then dry air. Dry air is a big one. But we get a lot of. I'm surprised we didn't get a question about African dust. That's always a big thing. The African dust is coming. And what the African dust is, it's dry air that comes off the continent, the northern deserts of Africa. The Saharan air layer is what it's called. And that's just very dry desert air that sweeps out across the Atlantic. And obviously if you have really dry air, it's hard to get showers and thunderstorms to form, and hurricanes form from showers and thunderstorms. And so that's a factor. There's a lot of other things, that trade, how strong the trade winds are. If it's wet over northern Africa, obviously the wetter it is there, it kind of tamps down on that dust and that dry air layer. And so there's just a lot of factors. And then sometimes where the monsoon trough sits up in Central America can be important, especially in the Caribbean, the southern Gulf of Mexico, the Bay of Campeche, and the eastern Pacific, because if that trough's a little further north, that tends to favor the Atlantic side for storm genesis, and so if it's a little further south, it tends to favor the East Pacific side. And so there's just a lot of things, just there's just a lot that goes into, if we have busy hurricane seasons, if we don't have busy hurricane seasons, El Nino, La Nina affects it too. I think we put a lot of emphasis on El Nino, La Nina in the Atlantic Basin, and believe me, it does have an impact. But there's a lot of other things out there that can impact the season besides El Nino and La Nina.
Yeah. And again, the numbers don't matter. It's the one that is coming to you that matters. And interestingly, some of the slower hurricane seasons have produced some of the largest hurricanes. And I think, is there any meteorological explanation for that, or is it just?
No, I think, and we've talked about this a little bit before. Even in a not active hurricane season, you have 4 or 5 named storms, which would be very, very inactive.
Right.
You're always going to find a window in that 6-month period where everything's going to line up. And if it all lines up, all these factors I've kind of just all talked about all line up perfect, you can get a monster storm, a big hurricane in an inactive season.
Yeah, Andrew.
Andrew 92, Alicia in 83. I mean, they're out there. I mean, the fact is you're not going to probably go 6 months without even with a lot of unfavorable conditions, it just being totally shut down and unfavorable. And then kind of the, even in big number seasons, Everybody focus on the numbers. In big number seasons, you can have a lot of what we call kind of trashy storms.
Yeah.
I mean, they get a name, and there goes a number.
Yeah.
It's a number, it's a named storm. But, it might be a 40-mile-an-hour sheer tropical storm out in the Atlantic or somewhere like that. And okay, well, we got the numbers, but this wasn't a big season. What we look at more than the numbers, everybody focuses on these numbers, but what we look at is what we call accumulated cyclone energy, the ACE. And that takes into account the strength of the storm, how long it's around. So you get these big, long tracked hurricanes from Africa all the way over to the Bahamas or the Central America. That's a lot of energy that storm is going to produce. And so that's a little bit of a better scale to kind of measure up season to season versus just the numbers.
Yeah. And I think you mentioned Alicia. That's a good one because that's one of those storms that formed in August. So, and not far off the coast. So it just got in, like you said, everything just aligned perfectly at that moment. The wind shear got weak. The ocean was already warm. It formed and moved in and really got strong pretty quick.
Mm-hmm.
Yeah. All right. Dan, thank you for that question. Nathan from Nashville asks, why are animals so sensitive to barometric pressure change? Well, I'm not a veterinarian, but
I'll let you take this one.
I do know that animals get restless before storms move in, and that is because of the pressure change. And for some reason, if I were a vet, I might be able to tell you, Nathan, but for some reason, they are more sensitive to the pressure change and then start, acting differently. So
we had somebody to screen these questions.
That was me. I figured that's why I got a toss. Well, that's okay. I'll do the best I can to answer it. But let's see. Yeah. So I don't know.
I've heard about this. It's probably worth digging into and seeing if there's any science behind it, or if it's more of the animals act a little different when there's a storm coming. I don't know. Yeah. And the other, a fair question is it the barometric pressure, or is it something else that results in animals realizing something's up?
Well, even people, my arthritis starts acting.
Well,
so
right. Well,
yeah.
Well, is it the storm, or some people, well, it's cold, and so when I get out of bed, I can't move my leg.
Yeah.
Or some people get headaches ahead of fronts.
Really?
And again, this may be pressure. I'm not a doctor.
Yeah.
So I wouldn't take anything I'm saying right now as any sort of truth or fact of anything.
All we can confirm is barometric pressure does exist and it changes.
Yes. And apparently it affects certain people and animals, possibly. I don't know.
Possibly, yeah. It would be a interesting thing to look into. Thank you for the question, Nathan. Anna from Houston asks, what steps should be taken to prepare for a hurricane? Wow. Okay. Well, that's another, could be a very long answer, but I say the best thing to do is, prepare different things. So have your hurricane kit, and I don't really like to call it a hurricane kit because it can apply to any type of thing that can make the power go out, which, that can be ice, freezing, whatever, or your power can just go out, and, water possibly too. But have your kit, and there's tons of different lists out there to decide what you want to go in yours, but have that done. But then there's other things, preparing your house, pruning your trees. If you keep your trees pruned, it's going to allow more wind to pass through and will decrease the chance of them being uprooted and knocked over. Your insurance for your house, if you live on the coast, there's evacuation routes to know where to go. If you just moved here, when I say here, I mean, if you moved to the coast, this is a good time to do some of those things, because you'll see that, as Jeff pointed out in an earlier podcast, most of the preparation is done 8 hours in advance. It's a lot. Most people wait too long. And then you go to a crowded grocery store, all the water's gone, the milk's gone, the bread's gone for some reason. I don't know why it's always milk and bread. For
I
me,
don't get milk at all for a hurricane, but
yeah, I
whatever.
mean, I would probably get,
Water,
beer.
I get water for sure. I don't
Yeah.
get the
Yeah.
spoilable stuff, but
Beer,
whatever.
beer and chips.
Well,
I mean,
there's a certain segment that buys that. Yes.
yes, yeah. So, but yeah, there are things that you should prepare for now, and when we are under a hurricane watch or a hurricane warning, there are other types of things you can do. Putting fuel in your tank, calling your relatives and tell them you're coming to stay with them, those type of things.
Yeah, I think the bigger thing is, we mentioned about the kit, and it's more of having a plan. You know,
Excuse me, folks.
is that a fire alarm?
No, that's the NOAA Weather Radio.
We must be going under a
We're,
watch.
we're recording this on an active weather day. I forgot to mention. So, yeah, that's what that was.
What was that? I don't know if I should run to the bathroom or run out or.
I'm looking out the window and I don't see anything. Actually, nothing's even blowing right now.
No, we went under a severe thunderstorm watch
Oh,
until 8 o'clock.
okay.
Congratulations.
All right. I'm going to jump off the screen here and go turn my radio down because it automatically.
So I think one of the things, like I said, having a kit's great, but having a plan is probably the better. The kit is part of the plan, and one of the things to think about is, when you have a plan is if you're in an evacuation area, and again, it's the coastal areas that evacuate from the seawater flooding, the storm surge flooding that can happen with a tropical storm and hurricane. So if you're leaving and you're evacuating, you're going to have a different plan. You're going to have a different kit, if you will, than somebody who's going to be staying in place and sheltering. And like Scott said, there's all kinds of lists out there. One thing I always tell everybody is you have to build your plan and your kit for you. And so the generic lists are great, but if you have certain medications you take, you have a lot of animals, or you have young children, all of this needs to be factored into that preparation plan of, coloring books for kids, something they can do if you don't have power and stuff like that, and extra food and extra water for animals and all of that kind of stuff. And so, and make sure you have enough medication and all that. Because you never know what's going to happen. A lot of people don't go into a hurricane thinking my roof is going to blow off and I'm going to get rescued out of my house. Because if you actually thought that, you probably wouldn't stay there, you'd leave. And so you have to be prepared for that unexpected, that you're going to have to move very quickly. You're going to get evacuated out, possibly on a boat or something, if your house starts to flood. And where are those key 5 or 10 items you're going to need to get you through, that you have to get you through until you can get to a location where you can get what you need. And medications, a little bit of food, some water, are those key things, the really key things. And I can't tell you the number of medications that are a white pill. And so people show up. I mean, we've seen this, and the only reason I'm bringing this up is because we've seen it happen. We saw it with Katrina when people arrived here at the Astrodome, and we saw it with the evacuation of Hurricane Rita. Is folks will arrive and they're like, okay, well, what medication do you need or do you not have? Well, it's some weird medication term. And well, what does it look like? Well, it's a white pill. Well, they're all white pills. And so at least having it written down on something, put it on your phone.
Take a picture of it.
Take a picture of it. So if you're put in that situation, you can say, well, this is it. And that makes things a lot easier for folks. But, it's things you don't think about when everything's falling apart.
Right.
You're not thinking about going and grabbing this and going and grabbing that. And, oh, I need that. You're going to think about it after you're gone. So just, build that plan for you, for your family. The generic stuff is a great starting point. All the lists, TV stations have them, Office of Emergency Management has them, FEMA has them. Those are great starting points. But then you gotta tailor it for you.
Yeah. And check on the elderly too. Of course, your family members, but also other people that may live in your neighborhood that are not. They just need help. They need to help getting the stuff and possibly evacuating or just putting their mind at ease. But help those folks around you too when we are being threatened by a hurricane. All right, great question, Anna. Thank you for that. Fred from Florida asks, when are you at risk of your pipes freezing? Well, yeah, I could understand somebody asking that from Florida. Probably not Southern Florida.
Well, you never know.
Well, that would be an anomaly, I
It
think,
would
to have
be.
frozen
It would
pipes
be.
in Miami. But yes, we could, we've seen stranger things, I guess. When are you at risk with your pipes freezing? Well, that a couple factors go into that, Fred. How cold the temperature is going to get, but how long the temperature is going to be at that, or yeah, how long it's going to be that cold. And that's why we have different criteria for freeze warnings in different areas, right?
Right.
Yeah. We have the same thing for heat too, but obviously somebody in Minnesota, is going to have a different criteria for a hard freeze than somebody in Texas because they experience it and their houses are built differently. Their pipes are buried deeper in ways that that's just something they deal with every winter. So, but how cold does it get? It just depends on how well insulated your pipes are. You should have your outdoor pipes insulated anyway, along with the sprinkler head.
Mhm.
That thing just breaks all the time for folks. So I think people are getting better at it. They're getting better at covering those things. But yeah, it has to get pretty cold for several hours for the pipes to freeze.
And it depends on the pipe. A lot of newer homes have the PEX piping, which allows the pipe, I guess, if you will, to expand and contract. So you don't typically see as many breaks as you do in the older construction homes, your copper and other pipes that they don't expand when they freeze. And so you don't tend to have as many issues in newer homes, and it just depends. We deal with that down here in the South. Texas over towards the Carolinas, southward. Northern areas, your pipes tend to not be as exposed as much. The plumbing's run a little bit different to protect against extreme cold. So they're probably more worried about extreme heat in places say like Chicago and the Midwest and the Northeast, because their homes aren't built for extreme heat. Our homes down here in the South are built for extreme heat, and so we deal with the AC and all that. A lot of places up north don't have that type of stuff, and so it's kind of it's always the price, the cost associated with the risk, right? So down here we just don't tend to get that cold that often, so we don't put a lot of emphasis on building homes for 10-degree weather, because most of the time we don't see that here. Unfortunately, when we do see it, it can cause a lot of problems. So you do have to take as much of a precaution as you can. When it comes to pipes in your walls and stuff, there's only so much you can do. I mean, it is what it is. But again, newer construction with the PEX instead of the iron or the galvanized and all that, we saw very few issues with some of the recent cold with the PEX stuff. So I think
Yeah,
it's a good way. And I'm not going to get into this. This is because there's a debate every time we get cold. Do you turn your water off and drain your pipes, or do you let it drip? And I'm not a plumber, and I have been, we have had some very heated debates and discussions in the emergency operations center on the messaging that we are going to have on letting it drip or cutting it off and draining. And I'll let everybody make that decision on their own. I think you can do it both ways. People do it both ways. It works both ways. It fails both ways. And there's an opinion. You can probably get 50 plumbers, and then each would have a different opinion on that. But
yeah. But you can definitely open the cabinets where
Yeah.
your sinks are, and that'll allow warm air in there. So that helps too. And yeah, and kind of along the lines of hurricane prep, don't wait till a day or so before it's going to freeze. Just wrap your pipes, put all that stuff on your irrigation systems now, and don't worry about it. Just leave it there forever
Till it rots off.
till it rots off. All right, Fred from Florida, thank you for that question. Tyler from Texas asks, how does one protect themselves in a lightning storm? Well, the first thing I would say is do everything you can to prevent yourself from being in a lightning or thunderstorm, which, it means looking at the forecast and, kind of evaluating your activity. Fishing, for example. I would not go fishing on a day where there's a 50% chance for thunderstorms, because you can put yourself in a spot that takes a while to get off the lake or out of danger. Golf course the same way, especially if you're walking on a golf course. There's a pretty good chance for thunderstorms that day. It may not be real quick for you to be able to get to shelter. I'll share a personal story I have with this. We were on a golf course, and everything I just said I violated. It was a good chance for thunderstorms, and we thought we could get our round in, and so we get to about hole number 6, and it just started pouring down rain. We could hear thunder in the distance, but we were in golf carts, so I guess that's one reason we decided to do it, because we could get to somewhere pretty quickly. But we did find a restroom. There were about 12 of us huddled under this restroom rooftop, and the rain really started coming down hard. And the thunder, it had to have been the loudest clap of thunder I ever heard. It was so loud, and it just was bright. I actually thought for a split second I was hit by lightning. Well, I was close. It hit the tree next to us. I walked it off. The tree was still smoking, and it was 48 feet away. So and it was just this real thin black line that went down the tree. So the lightning bolt itself is very thin, but my goodness, it can make some sound.
Yeah, I mean, like you said, it's best not to put yourself in situations. There's 2 or 3 situations. Golf courses are obviously not good. Beaches are another one. Beaches and boats are not good, and then swimming pools. Those are kind of the 3. Hey, you need to get yourself to something safer on those, and a lot of the reason is, if you think of golf courses, beaches, maybe swimming pools, you're the tallest object out there.
Yeah.
I mean, golf courses do have trees, which is exactly the situation you just described.
Mhm.
But on beaches and stuff like that, you are the tallest object. Lightning is going to tend to be attracted to the tallest object. The other thing with water, anytime you're around water, if lightning strikes in or near it, it can kind of transfer through the water. So it doesn't necessarily have to strike you directly for you to get maybe a zap. And so it's just best. And if you think you're if you're out on a boat, well, you're taller than the water, and so you tend to be that attraction for lightning. And so it's best to remove yourself from that situation, get into a location where you're protected inside some sort of a structure or something like that. Walking through parking lots, people have been struck. Planes get struck all the time. It's really not that big of a deal. The lightning kind of goes through the body of the aircraft. It can cause some issues, but for the most part, things are fine. It's the same thing with the car. You're perfectly fine in your car. Get to your car. It's actually one of the safer things.
Yeah.
The lightning will go through the body of the car and not through you.
Yeah. And the tires prevent the car from being grounded, as well as a plane is not grounded. So like you said, it doesn't go through you. There is, I've never personally tried it, thank goodness I haven't had to, but there is a lightning position if you're in a place where you don't have cover and you feel the hair stand up on your head or your arms or whatever. There's a pretty good chance lightning may be about to strike. There's a famous picture, hiking. That's another one too. There were some hikers This picture was taken back in the 70s. You can probably Google image it. And these hikers that they had long hair, it's the 70s. Anyway, their hair was standing way up, and unfortunately, they were after that picture was taken, they were struck. But you can. And again, a picture would be much easier to show, but you can squat down, kind of sitting on your heels, and try to stay raised on your toes with your heels connected, and then cover your ears for the sound. But the theory behind that is with your heels touching, that the chance, if lightning hits, there's a greater chance that it won't go through the center part of your body, your heart, which is what causes the fatality in a lot of cases, but will actually just go through your feet,
Right.
which will burn you a lot, but it's a lot better than dying.
Yeah. Most fatalities from lightning are cardiac arrest, because the lightning, they're not necessarily, the person's not necessarily struck by lightning, but it hits close enough that it goes up one leg, through your heart, and out through the other leg.
Yeah.
Or out through the other arm or whatever. But it's that going through the heart that creates the cardiac arrest. Most people die from that are struck by lightning. So again, keeping your feet together, not standing under trees. And if you think about lightning striking a tree, it goes down to the roots. If you're standing on top of the root, again, that energy is going to come up one leg through your heart, and then maybe out through the other leg or something like that. And so you don't know where all the tree roots are under there and all that. And so again, the best thing to do is get to safe structure, some sort of sturdy structure, or a vehicle or something like that, and take yourself out of the situation where you're vulnerable outside.
All right. Well, that concludes this round of Ask Weather Insights. We appreciate y'all's questions. Hope you enjoyed that. Jeff, always a pleasure.
Yes, sir.
Thank you, sir. Have a good one. Till next time.